Welcome. So my name is Sergio Santos. I'm a solution architect, account solution architect at ZEDEDA. So I'm based in Southwest Europe, in Lisbon. And I'm here to introduce you a practical example of Edge AI for object recognition use case that you can use in different market verticals. Retail shops to count number of people in the cashier, or you can use like in the oil and gas industry or in maritime, you can detect protection equipment. So this is basically a generic object recognition use case that we are going to show how to deploy. In this case, using the Docker Compose runtime infrastructure, and also deployed at scale in a fleet of 3 devices. So the demo workflow that we prepared here was essentially composed by 3 applications. So the AI piece, so the container that runs the AI inference pipeline, together with the business logic. So together with so we're just doing a single container. So we didn't split this in 2. So we have this one single container inference that in this case, this container can run on a GPU or without a GPU. So it basically, we made the container available in a runtime, in the Docker Compose runtime, and in that runtime you also make available the NVIDIA CUDA drivers, so that in case those drivers are there, in case there's a GPU available in that device, the container can actually consume those CUDA cores, right? So in this case, the inference pipeline is actually using an open source model from Meta, from Facebook, the ResNet model that is used generically to detect different kinds of objects in pictures, and is leveraging also the PyTorch framework for image transformation calculations and actually outputting them the result of the inference. And then the container itself will expose that information to business logic. And in this case, locally, you want to also to keep some that data persistent in the device. So we can imagine that this could be a ship that doesn't have internet access, or actually the information is only relevant local. In case of protection equipment, you need locally dashboard to alert the captain of the ship that there's an hazard or there's a problem. So we somehow need to keep the database. So in this case, we brought Prometheus, a time series database that will keep that inference data locally in a time series. And you also have a local visualization to actually present that data in a dashboard. So that's why you see these 3 applications, and they are actually available in this marketplace. And then from that marketplace, basically, you can deploy in a fleet of devices. We have 3 node devices, one with a GPU equipped, the other 2 they don't have. And the flow of them is essentially basically go from day 0 to day 2+. So where we start with without any edge node created in our platforms, we'll deploy the edge node, and then we'll trigger the deployment of this application stack, right, on those 3 edge nodes using automated deployment policy, right? And then at the end, we'll update basically this inference container so that we'll push the new version of that container, and we'll do it on the runtime without actually restarting the runtime, right? So technically, when this is doing a zoom in the edge node, so we pick that first edge node that we have a GPU, so a discrete GPU available. So when you deploy this AI inference container, our inference pipeline running on the Docker runtime with the NVIDIA CUDA drivers, so it will basically it will actually connect to the camera feed. So it's actually image processing, computer vision. So you basically connect to the camera feed. So the pointer to get there is the configuration parameter in our Docker Compose YAML. And then the user can also get the web interface that is exposed, so the business logic or the client logic is also exposed in that same container. So we'll get a picture like this. So we can see in the video stream, in this case from New York City, we can see the objects, car, person, buses, and you can have some statistics. And then these statistics are actually live in the web page. So we want basically to keep these statistics historically over time. So that's why the container also, the client logic of the container also exposes the Prometheus scrapper. So our Prometheus container running next to the runtime will scrap that metrics and keep it in the database, right? And then the Grafana basically can also be used to present those metrics in a time series, and the user can also connect to our Grafana and see actually those statistics over time. Okay. So essentially, this is the demo. How do we deploy it? So we have this concept of deployment project or deployment policy. So we saw already Terraform in action, and you can actually declare all these objects as part of the Terraform, or you can reduce the Terraform state so that we can just declare our devices. And you have a policy definition in the controller where you say that for this device, in this project, I want this application stack to be deployed. So we bring the nodes are part of the deployment project, and automatically the controller will create all the objects that we need in that project. So it will basically create these 3 applications that we see in the picture, the AI inference running on the Docker runtime, the Prometheus database, and the Grafana. And next to that, there are other elements. So you might need a network segment internally to connect to those devices. You might need other policies that you need to actually remote manage those devices, remote connected. So you see here edge view policies, node attestation. So all these are actually hardware level or maintenance level of policies for our devices that you also bring part of this deployment policy. Okay. So that's under the hood what is happening. So the Docker runtime that was we already explored. So here we present a bit more detail how it works. So we have actually a curated Docker runtime, and we have an agent running inside that Docker runtime that basically can grab and pull and push updates from the controller. So we have this ZEDEDA agent running there, which is basically getting configuration updates and pushing also state updates back to the controller, right? So, and our container basically is part of our Helm chart. Okay. So we call it this ZEDEDA ZIX. So we call it the Inventory and Configuration Services. It's a generic framework that it's available for any application in the marketplace. You actually use it with a specific communication channel here between the Docker runtime and it. So here you see basically the Docker compose YAML file, and you see in this case basically 2 variables pointing to our camera feeds, right? So in this case I have 2 camera feeds, and you also see the access to the CUDA cores. So we are using the NVIDIA CUDA cores available in our GPU. Okay. And then we also inject some secrets so that we can access the hash history basically with where our container is running. And you have some variables here so that you can dynamically push updates in this container image. Okay.
Does ZIX comprehend rollback as well? Is that just not sure?
Yeah. So basically, with this, we can basically push updates into the runtime. So we can just change tag or actually get state, so we can actually update and roll back the tags or the versions of these containers running in the runtime. So it's basically just a mechanism that we have. It's a generic mechanism to propagate configuration updates into the runtime and actually push generic state right from the runtime into the controller. Okay, so you can even develop your own agent, right, that will follow your own data structure, right, that you can use to export information back to the controller. And we have a single pane of trust where you can see the state of all your data. Okay. So let me jump into the video. So as I mentioned, we'll start from the zero. So we don't have any edge nodes deployed in the first moment. So we'll just go and so this is basically the default project. So where the list of nodes is empty. And then we're going to extort marketplace. So now we are going to see these 3 applications that we have in the marketplace. So we are going to see the Docker Compose runtime. We are going basically to check that we have here the Docker Compose YAML that I showed you with the 2 camera strings. And then the next, and here you see the GPU, right? So you see basically in the marketplace, you tell that this application requires a GPU attachment, a discrete GPU attachment. And then you have another version of this app without a GPU attachment requirement. And then we also have the Grafana container. So again, we in the marketplace we expose which ports are available, what is the image pointing to, so you can just point to any registry. And here you are going to define basically the deployment policy, right? So that's where you are saying that, okay, we have a deployment project. There are two policies part of this deployment, one for GPU nodes, another one for the GPU nodes. And as part of this policy, they are saying that we need to deploy these three apps for every single node that is part of the deployment project. So this is the version for GPU attachment. So you see the applications basically for the marketplace that are part of this deployment policy. Okay, the three applications that I showed you in the marketplace. So you see here that they require a GPU attachment for this version of the policy.
It's this unified policy in the ZEDEDA control panel and ZIC that is really the secret sauce here, is having that sort of scaling of the tool that's designed for dealing with just one site to being able to apply policies that use that same tool across potentially thousands of sites.
So basically you just define your policy and then you can use that across thousands of sites. So you just bring your nodes, right? And that policy, make sure that it's consistent across all those sites. So in this case, right now, I'm now deploying the devices, the Terraform. So we just need to declare the devices and make them part of the project, right?
With those policies, can you do like a phase rollout to different locations? So you're not pulling, the same container 1,000 times from all these different locations. Or if something goes wrong, you can kind of do a rollback before it hits all 1,000 of your locations.
Well, what this policy is applied basically to the edge locations, right? So this will be executed by the edge nodes directly, right? So we'll monitor the policy deployment on the flip of these devices. So if there's a failure in one of those nodes, basically we can move that node out of the project, or you can move that node into a different version of that deployment policy, right? So that you can hold back. So as you saw in deployment project, there are multiple policies, right? That they are triggered based on the association of the nodes to the project and the tag. So if it failed in one of those nodes, we can basically move that node to the previous version of that deployment policy, correct? And that will hold back to the previous version. Okay. So imagine that you have changed the application stack. So right now you have these three applications. You can add a new one. You will add a new policy with a new application, right? And then you move the nodes from policy 1 to policy 2 version, right? So right now, what I'm doing here is just essentially declaring the nodes, right, using Terraform again. So I'm just putting the nodes in the default project. So this is the variable, so I just have 3 nodes. So these 3 devices will be created under the default project. So I have some flags if device is GPU enabled or non-GPU enabled. I also define the IP address statically. And this is basically the Terraform plan for node creation, where I just declare the nodes. I don't declare any applications or the application stack. So all that will be brought in automatically by the controller based on this policy definition that I just showed you. Okay, so you see the tag. So this tag that we see in the node is actually matching a corresponding policy. Okay, so when you see some logic in the Terraform, you basically if the node has a GPU or non-GPU, it will basically attach the node to the GPU policy or non-GPU policy. Okay, so I just create the nodes. So the nodes will show up now as provisioned in the controller. So what I'm going to do now, so you see I have one node with GPU in this case. And the other two, they don't have any GPU attached. So what I'm doing next is just, I'm using Proxmox. So I'm using virtual nodes in this case. So I'm going to bring up the nodes. So before going that, actually now going to change from the default project into the deployment project. So even before bringing up the nodes. So what this will basically trigger the creation of all objects by the controller in those devices, in those nodes, right? So even if the nodes are not yet there, right, in the field, so we don't have any hardware yet running. So we just basically administratively moved the device from the default project into our deployment project. So they are gone from our default project. And now we go to the deployment project, and you see the nodes are there. And then if we inspect the node, you'll see now in the Edge app list, we see now our 3 applications already provisioned there. So as we're defining the policy, right? So we see our AI inference is attached to GQ. And now when you bring the nodes online, so the node will register to the controller, and then all this the application stack that we define the deployment policy will be automatically installed in these 3 nodes. So right now, so the node is just doing the normal onboarding process. So using a remote attestation and multi-TLS, right? So, and now that nodes are online, then it will start the deployment of our application stack. So now if I go to the list, so you see over these 3 nodes, right, we have in total 9 applications, so instances, 3 per node. So you see here that our applications are now coming online. So they are getting implemented, so we can monitor the state of all these application instances across the fleet of 3 devices. So now we have it online. So we can see that the application is running. We see that the service is exposed on port 8000. So this is one of the client service. It's a web service that you can connect. And we are going basically to just figure out what is IP address of that device. So 30, and then you'll connect on port 8000. And that's what we see, right? So that is basically a video stream. And you can see basically the statistics of the inference on the objects. So here you see it's a bit faster in the detecting it. This is running in a GPU. So, and then the next thing is how we keep that data, right? So we can actually remote access that node. So we can just check locally if in the runtime, if this process is running in a GPU. So right now I'm just connecting locally. So you see the NVIDIA utility that is showing that our Python process from our container is running on a GPU. Okay. And also we see the container running with our tag. It's right now it's draft 01. So later on we'll update this version of the inference pipeline container. So we see the same thing on the second node. So we have 2 nodes. So we have this consistent deployed across 2 nodes. In this case, there's no GPU. So you'll see the image is a bit slower in this case. So because it's not running on a GPU compared to the other device. Okay. So, and the same for node 3, right? So the node 3 is also running without the GPU, and we have the same logic. We can also access over the IP address. And you'll see that this is also slow compared to the first one.
Conceivably, there's no practical limit to the number of, or the variety of images you're using for this. You have 2. It demonstrates the platform, but you could have like 10, 12.
Yes, there's no limit. So you can have, in this case, I have 2 without GPU, or you mean the nodes, right? That we are talking here.
Yeah, I mean, to my sense, one of the big advantages ZEDEDA presents, and I think it's one of the reasons why so much of your customer base and use cases are on like that classic edge, physical or demanding environments, what have you, is an ability to support a real wide variety of devices for what amounts to one application, or one application set. And so it's really, I mean, this is a really good example of it, where you need to target maybe similar functionality to a lot of different types of edge devices, or even conversely, have more uniform edge devices, but different packages that you're sending out. And you can do it in a centralized and managed way.
Correct. So in this case, you use this policy, so you can actually just bring the device to the policy, and actually the policy based on the tags, which you can identify, okay, this device doesn't have a GPU, so this is the application stack that you'll pick, and you'll actually implement that version of the deployment policy, right? So that's what I'm showing here. So there are two versions of that deployment, and with this we can actually implement. Of course, the runtime, there are slightly difference to it, but we have those two versions in the marketplace. But the onboarding process is similar because we are talking about the same use case, right? So right now, the next step in this demo is just I already showed the Grafana piece, so I'm going basically to show how we can update that version of the Docker Compose using this Zix infrastructure that I mentioned. So I'm just going to push. So I'm going to show that I'm running basically this version draft 01 of our inference pipeline container. So that draft 01, and is what I'm going to do now is basically to select the list of our 3 runtime in these 3 devices. I will push this update to change the container image draft 02. And if I go now to, so this is actually the OPEX status you see here. So let me just pause the video. So the OPEX status you saw there in that previous frame. So this one is basically the update that the runtime is pushing to the controller. So you can just say, okay, I'm running, okay, this is my version of my container. So this right now is encoded, but what I did, I just used the API client on the side of it. So you see here the 3 nodes, and basically just tells that, okay, I'm running draft 02 already, and this is what the runtime is publishing back to us, okay? So as I said, it is generic infrastructure, so you can publish any JSON formatted content. So now I'm going to remote access again from the, so you can imagine these nodes are remote. So there can be behind firewalls behind that. So we can use this mechanism just to remote access the nodes. And then you can see that the device is already running the draft 02. And if I try to see now the UI as a new look and feel, so there's so it means that we actually updated our image in those 3 devices, right? So we see as well that was updated. So it's a slightly, we didn't actually start with runtime. We didn't redeploy everything. It just was a lightweight operation that we did in the runtime, and we use this Zix infrastructure to push the configuration updates into the runtime. Okay. So now basically I'm just going to remove it. I'm just going to put it back to its initial state. So I'm just going to attach again the draft 1. And that we'll see again the state already being published by our agent running in the runtime. So it's this publishing back to the controller, but now I'm running the version draft 01. And I should basically remote access again and confirm again that it's now draft 01 as well. So that it's back to this initial state. Okay. So, and then the NVIDIA utility is also reporting so you see here the UI is back to that initial state. The next, so you see this for the 3 nodes as well. So we did a bulk update, right, on those 3 applications from the controller. So you can also extract logs. So all these runtimes, the container can be exporting logs, and the logs are also visible in the controller. So you can see logs about the inference. So you can see persons, or so these are basically the logs of our Prometheus wrapper that is exposing locally. And you can also see metrics of our, like you can see CPU, memory metrics, memory utilization, and we can also see network utilization, network traffic. So we can also see here, for instance, the traffic towards the camera. So traffic towards the NVIDIA GitHub, for instance, and things like that to get the plates. So that's also visible in our statistics. So I'm just going back to the patch, all the patch envelope, all the plates are done. So now I don't want to use this split of devices anymore for HAI. I don't want to deploy anything else. So I will wipe everything. So I will just move the device from this HAI project into the default project again. So that's what I'm doing by just in the Terraform, by just changing the project assignment. So I apply now my Terraform. So the state will be changes for those 3 devices. So devices are gone for my HAI, and now they are back to default. And then in default, there's no application. So basically just wipe all that by just moving the devices from one project to another. So those 3 are now empty. So that's, I think, essentially what I wanted to show you.
I think from my perspective, all of that work you showed is really hard to do manually. And that is what we're really driving at right here, is the orchestration and the ability to have those apps and remove them without quite significant amount of work in our GitOps pipeline. So, yeah, great demo. Appreciate that.